Al-Dareyn Modern School hoyga aqoonta.
Hello students, welcome to physics class form 2. The chapter is force. The topics today we are going to cover Newton's law of motion and the problems on force and different types of frictions and more about the concepts of force. Let's start. Newton's laws. Whenever we in lower classes we heard about Newton. Apple is falling and he find something like gravity, right? Fine, right. There are three of them. How many? Three. They explain the motion of an object as resulting from the forces acting on the objects. Right? How many laws we have? Three laws. And what they are doing, they explain. These three laws explain the motion of an object resulting from the forces acting on the object, how it is acting, where it is acting, everything. So there are three types, three of them. Let's start. Now let's a basic thing, adding forces. Adding forces. How we need to add the force? Forces are vectors. Vector means force is a vector quantity. Vector means a quantity which has magnitude and direction. They have both magnitude and direction, and so add as follows. In one dimension, note direction is using of plus or minus sign. Then add like scalar quantities, regular numbers with no direction associated with them. Example, for example here we have a vector of 3 newtons plus and 3 newtons plus. So how many total? We have to add 6 newtons, right? Now 3 newtons plus minus 3 newtons means opposite. See here the vector direction, both are that side, but here this is in this direction and in this direction. In this direction 3 newtons of force, 3 newtons of force, 3 both are opposite, means it cancels. So it means plus 3 minus 3 will get 0 newtons. Will get 0 newtons. Fine, right. Newton's first law, as we discussed just now, there are three laws. Now we are going to discuss Newton's first law. We can also call law of inertia. Let's see. Consider a body on which no net force acts. No net force is acting. Suppose for example I am standing. A force is not acted on me, means I am standing, means I am at rest. Right? If the body is at rest, it will remain at rest. I will be at rest. I will be standing like this only unless someone comes and push me. Right? Means that is Newton's first law. It will remain at rest. If the body is moving with constant velocity, it will continue to do so. For example, look here. If an object is at rest, this is at rest, a ball is at rest, it will stay at rest unless a net force acts on it. Someone comes and hit to it, then only it starts moving. Unless someone kicks, it will remain rest. If an object is in motion, it is in motion. A ball is in motion, it will be in motion, it will stay in motion unless a net force acts on it. Means like friction, some ground is opposing to stop, or if you put a leg here, it will stop. Otherwise it will continues going. Means for example for this is second scenario is planets revolving around the sun. It is going on revolving. Not there is no such kind of topic like stopping, right? A chair is not moving. It means it is at rest. Means tendency to move, tendency to rest. Right? They are called the Newton's first law. We can also call law of inertia. If an object does not move, it tends to stay at rest. If an object tends to stay in motion, they are called Newton's first law. Next, let's see here one more example. A person driving a car and there is a wall. This is at rest, but this is in motion. Car is in motion. According to this, he is at rest in the car. It means both are traveling. Both are traveling. Don't let this be you. Okay, don't do this. Just an imagination. If you are traveling, wear seat belts. Okay, because of inertia, Newton's first law, objects including you, car and you, resist changes in their motion. When the car going 80 kilometers per hour, car is moving 80 kilometers per hour, is stopped by the brick wall. Sudden break. Your body keeps moving, means it is stopped, but you are not stopped. It is going on moving, and you fell down because of inertia. You are moving and you will be in moving position. You are in motion and you will be in motion. That is called inertia. If a sudden breaks, then there are no seat belts. What happens? It will fall down. Right? Next. Newton's second law. Newton's second law states an object acted upon by a constant unbalanced force moves with a constant acceleration in the direction of the unbalanced force. See here, suppose imagine an object is kept here and you applied a force. What happens? The object will move. That tells about the Newton's second law. Means when you doing something and it is moving, what you are doing? We are applying force. Force is nothing but Newton's second law. This law related to the unbalanced force, mass and acceleration. Unbalanced force, mass and acceleration. Newton's second law tells about F is equals to ma. F is an force, m is an mass, a is an acceleration. Unbalanced force or force which is nothing but Newton's mass times acceleration. Look here in a small example here. You can see a rocket, a plane or something like that you can imagine. Here, this is the first starting. Here there is a force. It is moving. The position is x0 and the time will be t0, starting point. And the velocity will be 0 and here m is 0. So when it starts here, right, changing the position, so we can tell here the time is t1, position is changed, velocity is changed and the mass, right? Now let's see. Force is equals to what is the change in momentum with the change of time, as we know this, right? Difference form F is equals to m1 v1 minus m0 v0 by t1 minus t0. Why we have taken this? Because force is equals to mass times acceleration, right? Mass, acceleration is nothing but v minus u by t, means v by t, means change in velocity. That's why we have taken in this format. Right, t tells about the time, x tells about the location, m tells about the mass, v is velocity. Now from this, take the constant m, right? M is here, we can say m is, we can say m1 because mass will not change. Okay, so m v1 minus v0 divided by t1 minus t0. So what we can change in the velocity by time is nothing but acceleration. Right, so F equals to ma. Force equals to mass times acceleration, and force is an vector quantity because velocity, acceleration, momentum and force are vector quantities. Let's do a small example here. A Newton force of 10 newtons. A Newton force of 10 newtons acts on a box. There is a box here. A force of 10 newtons acts on it, which has a mass. How much is the mass? 2 kg. What will be the acceleration? A is how much? Means just now we know the formula, that is F is equals to ma. From this, F is how much? 10 newtons. Mass is how much? 2 times A. So A is how much? 10 Newton divided by 2 is equals to A, 5. So totally how much you got? How much acceleration we need? Got 5 meter per square second. Fine, right. Next, one more here. Example 2. How much horizontal net force is required? How much horizontal force? We can write like this. To accelerate. Acceleration how much? 2 meter per square second. Of what? 1000 kg. Car. Car is how much? Means mass is how much? 1000 kg. Means he is asking a force which is acting horizontally. Means we know that F is equals to ma. From this, F is how much? We don't know. So F is equals to m is how much? 1000 times A is how much? 2. Means we will get 2000 newtons. How much force? 2000 newtons we need to move a car with an acceleration of 2 meters per second, which is having 1000 kgs. Next, we have a friction. What is friction? When you rub your hands, palms, it is nothing but friction. Right? What do you call that? This is a friction. See here, in the same way, when there is a brick, when you apply, so look here, pushing, and it is in motion. When it is in motion onto the surface, it opposes something here, right? Surface. That force is which is opposite, that is called friction. Like this. Friction, that is called friction. If you are going on doing like this, you feel something, some hotness, right? When cold times, cold areas, cold weather, what you feel something cold, and then you start doing like this, rubbing your palms, right? It means you want to make friction so that you can get in hot outside, right? So that is the friction. Means there is a opposing motion, right? Next, definition of friction. The opposing force. What kind of force? Opposite force, which acts in the opposite direction of the movements of the upper body is called friction. Upper body and lower body, when it is going to be contact each other and there is an opposite force, they are called friction. There are two types of friction. One is static friction and also dynamic friction. Now look here, static friction. Static means rest, not change. There is no change. When a force is applied on an object to move it, but it does not move. See, look here, a person is applying a force with certain angle of 32 kg, something kg of box, it is not moving, then we can say it is a static friction in between these two. But it is not moving. As the force applied is balanced by the force of static friction, then this is called static friction. Whatever the force we are applying and the friction is also having the same, some kind of same force, then we can say that it is static friction. Also, it ends with the beginning of the sliding of the object at a rest. Now, a simple example for static friction is wooden block kept on a table. Unless a sufficient force is extended, the block will not slide down the table because static friction holds it and resists sliding. Why it is resist sliding? Because it has a static friction. Imagine you are applying the force of 10 newtons and the static friction is also 10 newtons. Means how much? 10 minus 10? 0 means there is no motion. No motion. Here, same scenario. No motion. If we have equal opposite forces. Fine. Next. Look here, static friction. Friction is between two surfaces that are moving past each other. Example. Here's, look here, a balloon. what's happening? They are attracting each other. Take a balloon, rub to something like our hands, or you can take a silk woolen cloth, rub over it and then put near to your head. What happens? It attracts. When the balloon is rubbed on your hair, static friction is created. Or you can rub like this balloon, then we can find a static friction. A static means molecules or atoms which are at rest and it has some power to do the work. Next, kinetic. Kinetic means there is a change. Okay, right. Kinetic friction is a sliding friction. It is a force that resists sliding or skidding motion between two forces. Look here. Motion, friction. Motion, friction. Here, look here. Motion, friction. And different angles, we can say. Different scenarios. If a crate is dragged to the right, a friction points left. Friction acts in the opposite direction of the related motion and produce it. Now, static friction. Look here, one more static friction. The force that keeps an object that is not moving in its place. A vase on the top of a table is an example of static friction. This is an example of static friction which is not moving. The coefficient of friction means friction. How much friction it has. There is a friction. Then how much? That tells about coefficient. The coefficient of friction is a constant that depends on the materials. Two smooth surface, two marble stones and normal stones, right? The surfaces are different. The wall surface is different and the screen surface is different. So it depends. The coefficient of friction depends upon the surfaces. Pairs of material with more friction have higher coefficient of friction. Like the formula for coefficient of friction is mu k. That is kinetic. This is the coefficient of friction. Means frictional force and the normal force. We have to divide. So look here, an object on the surface. Now you are applying a force, right? And the direction of motion is here. This is a normal, and you are applying the force toward this side. And frictional force is opposite, and there is also a normal force, right? This gives about the coefficient. The mu k tells you how many newtons of friction you get per newton of normal. So do you use why UK has no units? Because it gives only a number. Let's have one problem over here. A 5 kg box is being pulled with a force of a 5 kg box means mass. A 5 kg box is being pulled with a force of 20 newtons. Force is 20 newtons. 5 kg box pulled by a person, right, with 20 newtons. A person is pulling a 5 kg box by applying a force of 20 newtons and it's sliding with an acceleration of 2 meter per square seconds, and it is moving, sliding 2 meter. Find the coefficient of kinetic friction. Kinetic friction means we know the formula. Frictional force divided by, right? How much? What is the formula previous divided by normal force? Now, if you use this formula, you will get the answer. Now, what is F? 20 newtons. Means how you will get the form? F minus frictional force.